Hello, good afternoon. How are you guys doing? Hope you have a great Ignite. Now this session is all about fun. I'll be showing you a lot of cool gadgets, small little maker stuff. I'm sure a lot of this you encounter in the Maker Den as well. But the whole idea of my talk is really to show you the seamless communication between devices and how we're doing that. The key takeaway in this session is how do you connect to the Azure IoT Hub, which is a really new service in Azure. We just launched this over at AzureCon. That was on the 29th of September. And we'll be doing that via the Azure IoT Protocol Gateway. And the reason for that, I'll explain that later in my slide. Before I jump into my session, let me just do a quick introduction of who I am. My name is Fai. I'm the Global IoT Technical Specialist. I'm based in Sydney, but essentially it's a regional role. I'm focused in Australia and New Zealand, but I've got my teammates spread across the world. So I've got, in this part of the world, we've got a team in India, in Singapore, Japan, as well as Greater China, and they're based in Beijing and Hong Kong, respectively. So for myself, I've been working with a whole bunch of really esteemed red carpet IoT partners. I believe some of you are sitting in the crowd today, so thanks very much for attending my session. Alrighty. All right, let's paint some context of what it is we're talking about. Now, IoT is right at its hype cycle. Right? I've walked into customer meetings where the CIO would tell me, "Oh, what's new? We've been doing IoT for years. Not just a few years, but like as good as 20 years. So what is Microsoft doing here with respect to this field?" It's just that it was known as different names prior to this. It was known as the industrial internet, M2M, or even before that, embedded systems. It's always been there, right? But what's different about it is that it's about how easy it is to connect your things, right? But beyond that, it's really about the insight of your things. Now, all those things, you may be able to connect that from yesteryears, but truly the value out of it, if you want to do advanced analytics, predictive analytics, and I kind of borrow something that Uli said in his session at 1:30, which he said, now IoT is just the beginning, right? IoT is not really exciting if you're not able to really produce that big data. So you need to have a big data problem in order for you to really reap the benefits out of IoT. So that's what it's about. But I also want to paint some context here related to customers who say that, no, it's nothing new, because, yeah, it's nothing new, because the assets, the IoT assets, have been deployed, it's running on the field, and that's what we call the brownfield scenario, right? And of course, you would have cases where a customer comes in and say that, well, I absolutely have nothing, so I want to deploy new sensors, new devices, new gateways, and how do I go about doing that? That's very much greenfield. Many brownfield scenarios actually exist today, and what we want to do is not to rip and replace, but really how do we play well with all these existing assets that you have in your environment. So if you go to a manufacturing company, they have all this deployed. In fact, they may have their own protocols in place. OPC UA is one of the more dominant protocols. But of course, you hear about other protocols like MQTT, CoAP, so on and so forth. As a matter of fact, my colleague in Redmond told me there are about 300 different protocols. Okay, so how do we support all of them? So that's really the gist of my talk. How do we support existing devices that speaks its own protocol, and how do we have them all play well together in the cloud today? Now, of course, the context is very much around creating the Internet of your things. And that is very much, yeah, it's marketing speak. that turns out to be the campaign from Microsoft with regards to Internet of Things. But it's true to the fact that it's about your things. How do you want to connect them? If you've got existing devices, how do you connect them in the fastest way possible, right? And if you don't have any devices, how quickly can you provision some new devices and get going, start monitoring what's coming through, look at the telemetry, and ultimately make sense of the data that's coming through. Okay, how many of you here have played around or have heard of Azure IoT Suite? Just a show of hands. All right, good, yeah. Quite a number of people. But for the rest of you, this is essentially the service that we've launched or we made available for purchase on September 29. But what that means is that We've made this available for purchase, but essentially some of the services within this suite are still on public preview. So this is to be expected out of all new suites coming out of Microsoft. You must have heard about Cortana Analytics Suite, which is essentially a group of existing Azure services. Some of them have already gone GA, and some of them have not. They are still in public preview mode. The Azure IoT Suite falls in that same category as well. So in a nutshell, what the engineering team in Redmond have done is that they've pre-packaged a bunch of services that makes it a whole lot easier for you to spin up, right? So you could almost imagine this is like your MSI for the cloud. You want to create an IoT solution, you say create, and it spins off a bunch of services under the hood. To be exact, we spin up 10 different Azure services. Not 10 different, but 10 instances of the Azure services behind the scenes. So you would expect some instances of IoT Hub, Stream Analytics, there's a document DB in there, so on and so forth. You can actually get into the details, especially at Uli's talk tomorrow. So I'm going to zoom in more onto the things on the edge, which is you've got devices or sensors, how do you get them connected? And really, we expect you to tailor the pre-configured solutions to your needs. So we're not saying that, yeah, just purchase one unit of Azure IoT Suite and you're good to go. You do that to accelerate your proof of concept or the IoT pilot projects you're working on, but we absolutely expect you to configure it to your heart's content, right? Especially if you're a system integrator, you're at least saving a lot of time, not having to figure out all these things, the plumbing behind the scene. You just spin up all those instances, but you have full access to everything that's under the hood. So for instance, if you don't like what's written in the Stream Analytics job, you want to change the SQL statements, the SQL-like statements, you have full ability to do so, right? And if you don't like how the output is being sent to an event hub, you want to send it somewhere else, you want to persist that into a Azure storage because you want to do, typical to any Lambda architecture, you want to do batch analytics, you could. Or you can also integrate with Apache, Spark, right? Apache Storm, so on and so forth. It's limitless what you can actually do with it. But just take home with you these 2 points. Pre-configured solutions. It's SaaS-like IoT service, but it's not full software as a service, not yet. Maybe one day we'll reach there, but right now we want you to build your intellectual property, your IP, on top of what we have. And so that you can accelerate POCs and pilots and move to production a lot faster. It kind of goes well to what I said. IoT is at its hype cycle. If you don't produce a POC soon enough, if it takes 6 months just to produce a POC, then pretty much lose confidence with the customer. So you want to do this really quickly. As a matter of fact, we have good success with our partners and customers worldwide where a POC takes just about days to like 4 weeks at most, just to crank something out. Right? And we continue to add more pre-configured solutions to it. The first one we've launched is a pre-configured solution for remote monitoring. In fact, that will be the basis of what I'll be demonstrating later. But we will soon follow up with predictive maintenance within this calendar year. And next year, we'll do asset management as well. Okay. So this is that really nice slide that talks about is a virtual cycle of like from the connected things to all the services you have in the cloud, from that hyperscale telemetry ingestion, that full command and control capability, as well as what you would do, right, once you've got that streams onto the cloud. And for guys who truly subscribe to the Lambda architecture, you will want to have processes that deals with the 3 layers, the batch layer, the speed layer, as well as the service layer or the interactive layer. And you can do all of that because once it's ingested through the cloud, through our IoT Hub front door ingestion service, it's really up to you how you want to play around with the data. Okay, so stream processing and predictive analytics tends to come in a pair. This is very much used for the speed layer. So in other words, looking at real-time data analytics. But in other case, you might want to have things which are just persisted into Azure's blob storage, which you can then do your own batch analytics thereafter. But you can also have very good workflow automation, and a lot of that is done through logic apps. So for instance, once you ingest the data, you would correlate the data streams with something that you have, right? An existing line of business application. And say if you want to get that connected to an SAP system, that workflow automation can be achieved using Azure Logic Apps. You write an API app, you drag and drop a connector onto the Logic App canvas, and boom, you have a full workflow pretty much designed, right, and ready to go. Okay? And there are dashboards, visualization. If you purchase the Azure IoT suite, you get 10 licenses for Power BI as well. So you can do all this stuff. Now, typically when I look at an IoT project, I can summarize into 3 parts. And these 3 parts are integral to any IoT projects. The first part is how do you connect and scale with efficiently. The second part, which is pretty much what happens in the cloud, how do you analyze and act on those new data that you've captured. A lot of these are telemetry, but beyond that, it could also be aggregated data, things that you have correlated with existing data sources within your organization. And finally, how do you integrate and transform this within your existing business processes as well? Okay, so 3 different parts. And depending who you speak to, some of them may be really, really good in the front part. Some are really good here. What I've discovered working with our Azure Red Carpet IoT partners in Australia is that I guess very few people could actually span across this whole thing, but that means there are opportunity to work together. So oftentimes I play a matchmaker role. So if someone is really good in this part, I kind of matchmake that partner with someone who have been, been playing around or developing embedded solutions for a long time, because it's a skill set that takes time to build, but at the same time, it's not necessarily something that everyone wants to build within their core practices. I'm just going to go through the slides fairly quickly because I want to spend a lot more time on the fun stuff, the demo that I have. But this is a really good view of the architecture around Azure IoT services. At the front door data ingestion service is the IoT Hub. You may ask, how is this different from the Event Hub? The Event Hub is meant to be one way, so you're just ingesting telemetry. But in the case of IoT Hub, it's not. It's two-way. There's ability for you to send notifications back to the devices in a command and control type of fashion. So that really sets it apart. And besides that, the IoT Hub is built for IoT scenarios. It can scale up to millions of devices. When you provision a unit of IoT Hub, it supports 1 million concurrent devices. Okay? How is that different to Event Hubs? Event Hub supports up to 5,000 concurrent AMQP connections. Now, ultimately, they speak AMQP, but the contrast is pretty obvious there, right? One supports up to 1 million devices. One supports concurrently 5,000 AMQP connections. So in this case, there is a line of separation between field and the cloud. And why does this exist is because, I'm going to stand a bit to this side as well. The reason behind this is because of the brownfield scenario. There are devices which may not be capable of connecting to the internet, or maybe simply due to the corporate IT policies, those things are not meant to connect to the internet. So as such, you would have a protocol gateway that kind of bridges between the two. Okay, so in this case, I've got some IP-capable devices. Maybe it speaks a protocol that is not accepted out of the box in IoT Hub. So out of the box, we support AMQP as well as HTTP 1. And when HTTP 2 becomes ratified or whatnot, then we'll support that as well. Okay? Before any other protocols, those 300 different protocols that's out there today, you pretty much achieve that using a cloud protocol gateway. And you can scale this anyhow you want it. Okay? But there will be some IP-capable devices that can actually initiate a connection directly to the cloud, and you do that. As a matter of fact, the new lab in MakerDan that I've worked with Dave Glover has that feature built in. So head over to MakerDan, try out the lab, and you see how a Raspberry Pi running Windows 10 IoT Core, so essentially running a UWP app in there, is able to communicate with the IoT Hub. And I've done it in a sense that it's going to go pretty low level. You are essentially using your own libraries for creating your shared access signature token. It's intentional. You can go through that in the lab. Then you have a bunch of private area network connected devices, and these devices are never meant to be connected to the internet. So as such, you would have a protocol gateway sitting on the field or on the edge, and this acts as the field gateway. In this particular implementation of the Azure IoT protocol gateway, we can actually do both. So in my demonstrations later, we'll be showing you at first and foremost, how do you build a field protocol gateway, and then how do you deploy this onto the cloud as worker roles. And behind the scene, remember like what I said, there are 3 parts integral to any IoT solution, and so you still would need to do your event processing logic, and this handles both hot and cold paths. So that translates, or that gets mapped over to the speed layer in Lambda architecture, as well as the batch layer. So Microsoft speak, we call that hot and cold path. But we totally understand that the Lambda architecture is highly popular, so a lot of people understand that really well. And besides that, you have device business logic, connectivity monitoring, and some of this logic may be transferred to be sitting on the edge as well. So that becomes a lot more exciting. So as a matter of fact, in my demo, I have a real field gateway device I have on loan from a partner. I'll be showing you how that works. So a lot more device business logic actually sitting on the edge. So you'll be kind of like distributing that logic between what sits on the cloud and what sits on the field. And finally, you have one that that handles the application device provisioning, as well as the management aspect of it. So what we have today, there are APIs available, there are SDKs available that makes it a lot easier for you to provision your devices. But moving forward, remember the third scenario that I said will be available sometime later next calendar year is for asset management. So that you can almost consider that to be MDM, or mobile device management for the Internet of Things. Okay, but that's not available yet. But currently, you can still provision your devices. You can actually issue keys, have that per device authentication, so on and so forth. So why use field or cloud gateways? I've alluded to the reason why we're doing this, and of course from that previous diagram it shows it was pretty obvious why you need a field gateway, especially because the devices are never meant to be connected to the internet, to the cloud, so you have a field gateway there. But in some cases where you're using a protocol that is not supported straight out of the box, that's when you have a cloud gateway that acts as a translator. But there are some good reasons for it, and it can be summarized in the following. Number one, we're doing both bi-directional communication. So it's D to C as well as C to D messaging. So that's a given. That's what you expect out of the capability in a field or cloud gateway. So number one, just like what I've explained, one of the key features in IoT Hub is that you can scale simultaneously to millions of connected devices, and that's what you can do. And you want to do per device authentication and security. So that's really, really powerful. Previously, for any front door ingestion service, you pretty much create a SaaS token and you sign that using a policy that you have. Like in the case of Event Hub, you create a shared access policy, and that shared access policy is used to sign a number of devices. That's not the case with the IoT Hub. With the IoT Hub, you would create, using one shared access policy, you would create or register those devices, but subsequently, each one of this device would use its own primary key or secondary key to create a shared access security token in order to authenticate with the IoT Hub. So that's a lot more secure. Now, in case if the device has been compromised, you could actually go into the IoT Hub and blacklist. Basically, you just change the status of that device to disabled, and that's it. That device would not be able to send any telemetry, nor will it be able to accept any commands from the cloud. And if you read some of the blog postings from Clemens Vasters, Elio DiMaggio, talk about the service-assisted communication, and this is exactly the implementation of that. And from a security standpoint, it also makes sense. So communication is always initiated from the device itself. Okay, so even in a command and control scenario, it's never a case of the cloud calling your device or calling your field gateway and say, hey, wake up, I've got a command for you. There isn't such a thing. when it comes to the Azure IoT suite, because it's always initiated from the edge, whether it's from the device or from the field gateway. Okay? And of course, through this method, we'll be able to support multiple IoT protocols, those 300 protocols, and you can drive even more device resource optimization of what sits in the gateway itself. And you have more scenarios, right? So it's not limited to this. In this current version, that's what we do. But who knows what other IoT scenarios that actually make sense. But the good part of this is that the service is there, and we absolutely expect you to tailor make it. But if you have got any really, really unique scenarios, do let me know, because that's when I can actually provide the feedback to the product engineering team. Yeah. So let's take a look at the IoT hub's endpoints. Remember earlier I was saying that per device authentication, this is pretty much the architecture that allows that to happen under the hood. Now for each device, it has its own endpoint. And its endpoint would be either an AMQP endpoint or a HTTP 1 endpoint. It doesn't really matter. But ultimately, you have a device to cloud send an endpoint and also a C to D queue endpoint. Right? And each device would have its own endpoint. Okay? That's how we scale up to that. If you have field gateways and cloud gateways, that's exactly how it works as well. Because the field gateway or the cloud gateway is, I wouldn't say it's emulating the devices, but it's actually connecting to the IoT hub on behalf of the sensors, the devices, actuators, or what have you on the edge. Okay? But we also have endpoints that faces the backend services in Azure. And one such endpoint is the D2C receive endpoint. Now this is really interesting. This endpoint over here, the D2C receive endpoint, is fully compatible with the Event Hub endpoint. So what that means is that if currently you have an event processor host that's running on a worker role, which is essentially consuming all the events that has been ingested in the Event Hub, you don't even need to change a single line of code on that event processor host. All you have to do is just grab this D2C receive endpoint from your IoT hub configuration, smack that into your configuration files of your event processor host, and you're good to go. That's it. Okay? So this is what we mean that this endpoint is fully compatible with with Event Hub. Same thing how we could actually achieve no code, no T-SQL changes in Stream Analytics jobs. Because in Stream Analytics jobs, you would have a job that sets the Event Hub as an endpoint, as an input. And if you want to replace that Event Hub with the IoT Hub, it's pretty simple. All you have to do is just go in there, put in the connection string for this D2C receive endpoint, and you're good to go. Right? And for command and control, there is also a C to D send endpoint. So it's a specific URI that, again, is per device. So once you send anything, any JSON, payload, commands, or whatnot, that goes to that endpoint gets delivered to the devices. Okay? And besides that, we've also made available some other endpoints for message feedback and monitoring purposes, which is really great, right, if you're building up a metering solution. Okay? And you have device provisioning and management. So currently in the remote monitoring solution, we have that available. And all that is done through a device identity management. It's all exposed through APIs. In fact, the bulk of that is all encapsulated in the Azure IoT SDK. Fully open source. It's available on GitHub. I'll show you where you can actually grab that. Okay? And of course, you go to the Azure portal to do your IoT hub management. All right, dive in a little bit deeper. We're kind of like peeling onions here, right? So again, I'm trying to convince you why you want to do this. Again, because of brownfield devices, sensors, we need to support those existing IoT scenarios, so it's great to use a field gateway. But what we figured out is that that's essentially the IoT world today. For many IoT projects, when we go into to talk to the customers, they already have field gateways. So it's nothing new within the environment. So what we want to do is to figure out a way in which we can co-locate some of those intelligent services, have an agent that's built using the Azure IoT SDK to be sitting on the field gateways so as to enable that service-assisted communication with Azure IoT. okay? You can also do your own custom protocol extensibility and adaptation. And this happens very often as well. I was just talking to a partner, a startup, who's based in Brisbane, and have created their own protocol like 4 years ago. It's based upon UDP. So does it mean that, wow, you speak UDP and I'll just drop you from supporting? No, not the case. So what we could do is to ensure that whatever they've built, we can plug that in within the Azure IoT protocol gateway framework, and it will still work, right? Because there are still benefits of getting that telemetry ingested through the IoT hub, because that's not a problem that everyone wants to solve by themselves. Because you start thinking about hyperscale, essentially the IoT hub is that IoT service, platform as a service, if you will, right? So you still want to make use of that. Then you want to connect to devices that are potentially deployed in untrusted physical space. Yeah, absolutely. Some of these devices may not even have capabilities to have a TLS connection. So as such, you can't even have SSL, you can't have TLS. In some cases, it's so stripped down if it's a MCU, right? You don't even have access to crypto libraries. So which means you cannot create your SaaS token, right? It goes down to that. So you need a field gateway to kind of provide that bridge, right, between that device or that sensor in the field with what have you in the cloud. And this is really interesting, edge intelligence and analytics capabilities. Some of our partners and customers have asked that, hey, you know what? I understand what Microsoft is doing. You have this brand new shiny IoT hub. You just want us to send all our telemetry to it because you would make a lot more money, right, through those events. Well, not quite, right? Because we would also tell you that you may not want to send all your telemetry to the cloud. And how you would achieve that is that you have a really intelligent gateway, a field gateway, that would aggregate the data, filter the telemetry, right? And even have some simple event rules processing, and that's what we call like CEP on the edge, complex event processing on the edge. You might have that. And so that's a really good place for you to put it on the field gateway. Like my colleagues in Europe, they have a customer who has a field gateway that's sitting in a tanker, right? So the ship sails about, and you don't have internet connectivity. Sure, you have satellite, but you can't take that for granted, right? So the only time when there is connectivity is when the ship is at the port, right? So you want to have all these capabilities built into that intelligent field gateway. So whenever possible, you would kind of like send all this telemetry in batches. And by the way, the Azure IoT SDK allows that feature. It's got that send batch async method, which allows you to send all that. And it's also a good way for you to save some money because you don't just send a message that represents a very small data point collected from the sensor. You can group them in your field gateway before you send them as a batch to the IoT hub. Okay? So that's a few tips of teaching you how to save some money. Here's a typical brownfield scenario. Device captures telemetry from sensors in the field. Then you may have a custom messaging broker because none of these things are new, right? You've been doing this for ages. Your customers have been doing this for ages. So you have got your own messaging broker sitting on the field. Maybe you may even have some of those instances spun up in the cloud, right? So that forms your cloud, your custom cloud gateway. And you also want to do command and control. And it turns out that, yeah, a good partner of ours, CDM, they're based out of Melbourne, but they do have offices around. A good partner of ours as part of the Australian Azure IoT Red Carpet program. And they've got a field gateway called Nomad. So what this is a Windows embedded-based intelligent gateway that actually does a whole bunch of stuff, pre-processing before sending the telemetry to the cloud. And it's actually built specifically for a scenario which is logistics and also fleet management. So essentially you have a box that is connected onto your fleet asset. So in other words, that vehicle. And that box is pretty ruggedized. So I'll show you how that looks like. So this is what a brownfield device actually looks like. Cool. They don't manufacture the boxes. It comes from Advantech. Can you actually see that? Here you go. Here's a really nice box. It's got antenna built in, right? Some ports. Now I don't claim that I'm an embedded developer, so a lot of this stuff I'm just learning. I'm more a cloud guy, but yeah, you got ports in here, and then this sits right on the edge. Okay, and I've got this other one. This is really ruggedized, so you can see there's pretty beaten down. So you guys want to catch this? Yeah? Who's ready to catch this? Woo. I might kill someone with this. It's not too heavy, but you can say this goes into armored vehicles. Yeah. So that's the sort of form factor, and I think there's a reason why our good partners in CDM actually ship this units to prove a point that this is pretty much well used in the field. So we've got David Carrington who's kind enough, he's sitting here. If you've got more details, you want to ask for more, that's David sitting in front. Yeah, I really appreciate what they've done in loaning me a couple of these units, because this is going to form the basis of my demonstration. All right. So what am I going to present or demonstrate? Let me just jump back to 5. Okay, I'm going to connect to brownfield sensors and devices, and I'm just picking MQTT as the protocol that I'll do adaptation between what you have on the edge as well as what we accept in the IoT hub, which is AMQP. I will show you a concept of the Azure IoT Field Gateway as well as the Azure IoT Cloud Gateway. And plus a bonus, I will be using a really nice small little sensor device. And I'll show you a couple of options of connecting that as well. So here's, going back to that diagram, here's how it works. The laser doesn't look too well, so I'm sorry. So guys over there, you might have to see what I'm pointing over here. So the first thing I'll do is I'll demonstrate the Azure IoT Field Gateway is implemented as a console application. Of course, who runs a console app, right? Most likely you'll make that into a service that's running on the Field Gateway, and you're, of course, more than welcome to do so. Oh, sorry. Yeah, I'll run the Field Gateway, and it accepts MQTT over TLS, right? And the reason for that is because of security. You need those devices that talks MQTT, and it essentially sends a username and password, but not over clear, open text, but over TLS connection, right? So that goes through the IoT gateway. However, you also see I've got a device here called the Node MCU. This is based upon, it's a development kit. It's pretty recent, and I got this I borrowed from Dave Glover, the guy behind MakerDen. It's got a ESP8266 Wi-Fi. It's really affordable. That whole dev kit costs just about $12. In fact, if you just go for that Wi-Fi module, the ESP8266, it costs just about $6 or $7. That's just about it. But it's really stripped down capability. It's not even able to do MQTT over TLS. So that's where it gets more interesting. Hence, the more reason to have a Field Gateway that does that protocol adaptation, okay? But I also have a Azure IoT Cloud Protocol Gateway that sits in the cloud. In fact, it's deployed as Azure in Azure worker roles. And that's really meant for devices that are IP capable, they're pretty capable, like in the case of a Raspberry Pi, and it can send MQTT over TLS 1.0. And I also have Raspberry Pis running Windows 10 IoT Core with a UWP app running on it that is able to talk AMQP directly with the IoT Hub. And then, of course, you can do all the other stuff, fun stuff over on this side. Now, my talk is all on the left-hand side of the IoT Hub, okay? It's not that I can't talk about the rest of the things, but that's what I want to achieve within this session. So let's jump right onto demo. I have just about 40 minutes to show you what I want to do. Let me jump onto my laptop. Okay. So first thing first, remember I opened up my talk talking about the Azure, the Azure IoT suite. You might be wondering, where do you provision this suite, that pre-packaged solution? It's available in its own microsite, It's called https://www.azure-iotsuite.com. So once you get in there, you will see if you provision some solutions already, it sits there, but most likely you will only see this. When you say create a solution, it tells you what's available currently, which is remote monitoring. Predictive maintenance coming really soon within this calendar year. So right now you can only select remote monitoring, and it tells you at a very high level what gets provisioned behind the scene. So no surprises. You get one high frequency unit IoT hub, 3 stream analytics jobs, so on and so forth. Because this is the IoT hub is still available, it's only available on public preview, so hence it's only available in a number of regions. The closest to us is East Asia, which is essentially the data center, the Azure data center that sits out of Hong Kong. Okay? But of course, we expect to have more data centers. I'm sure that the number one question I'll get after this is, when is it coming to the Australian DCs? Right? For that question, save it for Uli Homan. Okay? So once you do that, it provisions it, and everything sits nicely within its own resource group. Okay? The one I've created is called Feister Remote. You can see it's got 10 instances of Azure services all created behind the scene. Okay, and what I'm interested to delve into is the IoT Hub. So this is a new logo for IoT Hub. Once you click on that, it shows me that for a unit of IoT Hub, I'm given a daily quota of 1.5 million events, and this means both, ingress as well as egress. Okay, 1.5 million. If you exceed that, what do? You provision, or you just basically scale it up to another unit. That's what you do. Then it supports 500 devices for that unit. So currently I have a number that's created. All right, what's next? So how do you get started creating an Azure IoT protocol gateway? It's pretty simple. All these are being open sourced on GitHub. So just go over to this address. Don't worry about writing this down because I've got all these resources being spelled out in my presentation slides. But here's where it sits, the Azure IoT protocol gateway. And most recently, just as recent as 10 days ago, we've made a commit on the master branch. So let's take a look at what happened behind the scene. So if you click on this note here, it says that, well, as long as not all Azure services support Azure SDK 2.7, we have to downgrade 2.6. Now this wasn't the case when we released it at AzureCon. There was no such requirement. So when I sync my clone GitHub repo sitting on my machine last week, I got a nice surprise. It's like nothing works. Okay? The reason behind that is because now we have to downgrade it to Azure SDK 2.6. And Azure SDK 2.6 only runs in Visual Studio 2013. So note to self, you would need to have 2015 and 2013 running in this particular instance. So that's what I'm going to do. All right? Of course, before that, let me just jump back. Very important, I need to get the URL in which I'll clone this project. Okay, let's run Visual Studio 2013. Alrighty, let's go to Team Explorer. Go to My Projects, connect to Team Projects. Let's put that GitHub URL here. And for this, I'll call this .ignite. No. Show, yep. All right, so what it does, it will clone that repository, sits on my local machine. If I double click on that, launch the solution. Now, first thing what you want to do is that you want to rebuild the entire project, right? Yes, you can do that. However, none of the NuGet packages has been installed. What you do is then you restore. Now this is going to download a whole bunch of missing packages because there is a dependency on a number of things. If you go to the GitHub page, it will tell you sufficiently what are the dependencies, including .NETty. .NETty is a really nice way in which you build a bootstrapper so that you create a TCP socket that's listening on the MQTT TLS port, and then also you'll be able to add different handlers onto the .NET pipeline. So in other words, if you want to do the TLS handshake, you want to decode the MQTT messages, everything is pretty simple to add it within its pipeline. Now this is going to take a while because it's going over to the internet to grab all of those packages. Something I noticed is that once after this, you click close, assuming you've downloaded all the missing packages, the NuGet packages, you do a rebuild, it's going to give you an error. What you do is, I learned this the hard way, is that you go back into NuGet, and under install packages, you would be able to see, like in a while, you would see Microsoft.Azure.Devices.Protocol Gateway. Click on that and uninstall this from all of the projects within the solution. Okay? Uninstall first, and thereafter, reinstall it. Okay? There's something that's broken. I'm not too sure. I'll provide that feedback to the team who is building this. Then you reinstall it, but you reinstall it excluding one particular project, which is under your source folder, this one, protocolgateway.core. Okay? Now I'm not going to wait for it to download all those missing packages. Just like a good chef, I would have pre-baked this before this. So let's open. Let's go back to projects. I've created one called Ignite. Let's open the solution. So this is all done nicely. In fact, this is what you should have for your NuGet packages. That's what I meant. Under Install Packages, just scroll down to Microsoft Azure IoT Protocol Gateway, manage, and install this on all of that except for this guy here. So this is a no-no, right? Do not install that onto Protocol Gateway because essentially protocolgateway.core is that NuGet package, right? So don't do that. So once you've done all of that, rebuild, and you're good to go. Now, there are 4 parts of my demo. I need to really speed up here. The first part is about running my protocol gateway as a console application. Okay? And what I do here is that I just want to modify the app settings here for 2 projects. One, which is my console project sitting here. Okay? And then I'll also need to modify the app settings for my unit test, which is sitting here. So let's start off with the console app. What's required? Oops, not this one. So let's take a look at what are the app settings for this. So first and foremost, I need to get the IoT hub connection string for that particular device. And how MQTT works, again, this is not about protocol, so I won't be really going into details about what MQTT is, and neither is this a protocol debate. I'm not saying what protocol works better than the other. I'm just saying that this is, in this current implementation in the GitHub project, you get the MQTT protocol adapter pretty much out of the box. You have your own custom protocol adaptation. What you do is that you take a look at this, and you will be implementing your own protocol adapter. Okay? But how this works is that now there's a thing in MQTT for session state, right? Session gets persisted. How we implement that is by persisting that onto a blob storage. As for quality of service QoS2 messages, which means for those messages that has to be delivered exactly once in MQTT terms, that is actually being persisted or rather queued to a Azure table storage. Okay? So I'm going to do 2 things. I don't want to use my local development Azure storage. I don't want to use a local emulator. I'll be pointing this directly onto my Azure service. Now, when you get the Azure IoT SDK, which by the way is another GitHub project, which is open source, it's sitting here. Okay, Azure IoT SDK. There's some really nice tools available, and one that I use constantly is called the Device Explorer. So you get this source code is available. In fact, if you want to build your own device provisioning application, like your own Internet of Things licensing server, you would take a look at Device Explorer and see what it does behind the scene, okay? But I've got one running here. So all I have to do is just go to the Management tab, List, and so let's say if I'm emulating this particular device here, Pfister Note MCU. What I do is that I copy connection string, go back to my protocol gateway, okay, and just put that here. Now I've got my cheat sheet over here. So I'll just copy the rest of that and drop them here. So you don't have to see me typing. Save that. Remember the other place in which we need this is in my protocol test. There's also an app settings configuration file. Same thing. Drop that here. And for my IoT connection string, this is the part where it requires not the device connection string. Okay, it requires the IoT hub owner connection string. So what I'll do is, well, a number of things that I can do. I can go back to my Azure portal. Under shared access policy, you can see there's IoT hub owner over here, right? So all I have to do is, you guys blink. Oops, that's not quite it. Connection string, it should be this one. All right, there you go. I just want to make sure, is this the IoT hub owner? Yep, it is. And save, that's it. All right, and besides that, I should probably give this a name. Okay, so let me just uncommand that. If I remember what it's called Pfister Note MCU. Save it. Now there are a bunch of unit tests that is available here in your test Explorer, but the one that I'm interested in is called the basic functionality test. So let me just run that. What happens here is that the unit test is intelligent enough to know that, hey, there isn't a field gateway, so I would instantiate a field gateway by myself. Okay? But in other cases, what I want to do is to run that field gateway as a console app and have my unit test talking to it by referencing its IP address. So that's the right way of doing things. So as a matter of fact, later when I deploy a field gateway onto the Nomad box from CDM, that's what I need. Right? I need it to be running as a console app, and of course, if you want to build this as a Windows service, you're more than welcome to do so. If you want to take a look at the source code, while this is actually running behind the scene, everything is running in this end-to-end test. Okay, so you can see that these are the telemetry that's running. And it's doing a whole bunch of stuff. The interesting stuff actually happens here. What happens in a server bootstrap? You create a channel, and then within your pipeline, you will add your TLS handler, right? You create your own MQTT decoder. So this is the part that uses the .NET GitHub project. Okay, and besides that, you're also logging everything. So all cool. So you can see here, what happens is like, wow, it's passed within 39 seconds. But how sure are you that things did get ingested? A pretty good way of knowing that beyond just trusting your unit test is that let's see what happens under the wire. The Device Explorer is also a very good tool for that. So I can actually sniff the JSON that's coming through the wire. Enable, click monitor. In fact, I should have done that earlier. No worries. What I'll do is I'll rerun this test. Okay, bring my Device Explorer back into view. So in a while, you will see that I would have two events that has been published from the unit test. And actually, what happens behind the scene, which I'm not showing here within this window, because this is only looking at what's coming through the D2C receive endpoint, right? So I see that I'm sending a QoS 0, and then I'm sending another one. This is most likely QoS 1, Quality of Service 1. In our current implementation, we only support QoS 0 and 1 for sending telemetry, but for command and control, we support up to QoS level 2, all right? So that's what came under the hood. If you want to run that console application, you can absolutely do that. And what I'll do is, let me just go back to my project here. Under console, rebuild. In fact, I don't have to do that. Just get the project folder. Open up your Windows Azure SDK environment. In fact, it'll be good for you to run this as an administrator because essentially you're creating a console app that opens up a TCP socket connection and listens on that particular port, right? So let me just paste that through here. It's being debugged. All right. So this is my field protocol gateway running there. Let's run it. So when it starts up, it will tell you a couple of things that is listening at a particular port. So for MQTT with TLS enabled, the socket is created on port 8883. If you're running MQTT without TLS, so just basic stuff, that's running on port 1883. Okay? But in this case, we've got TLS enabled. It's going to take a while for this guy to wake up. But at the same time, I can go back to my test project, and this time around, let's go back to my app settings. Let's uncomment this line and point that to my local host. Just put 127.0.1. Save that. Let's wait for this guy to wake up. Come on. Let me just cancel that and run that one more time. All right, here we go. Okay, back to business. So it says that it's been initialized on the TLS endpoint listening on port 8883. So we're running essentially a field gateway on my machine. I've got my unit tests ready to go. So let's run that again. Now, how many of you guys here are really into MQTT? Just to see a show of hands. One. All right, good. So don't grill me about MQTT, but the rest of you, that's good. This is you're learning about what happens behind the scene in MQTT. If you take a look at what comes under the wire, this is it. A whole bunch of things like the first message that goes through is connect, right? And then the gateway respond with a connect acknowledgement. And then the device or unit test device actually subscribes. It gets a subscribe acknowledgement. Then what it does is that it sends two publish message, right? With a QoS of level 1 and level 0 and level 1. Then it gets a publish acknowledgement. Then this three publish messages, MQTT messages, is from the cloud back to the device. So it works exactly the same way it publishes that. But what's interesting behind the scene is that you've got one of those published, one of those C to D messages is of QoS level 2. So that means a whole bunch of things happens behind the scene. First, you need to tell the client will say, yeah, I've received that. Then the client will say, all right, release it, and finally complete. And ultimately, disconnect. That's what happens behind the scene. Okay? So we've got a field protocol gateway running here. So let's very quickly move on to how about deploying this as a cloud gateway. So this is in case where it doesn't quite make sense if you've got IP-capable devices and you don't want to have another field gateway sitting on the edge. You want each one of those Raspberry Pis, if you will, sending telemetry directly onto the cloud, and it's a lot easier for you to scale out or scale down. So as such, you will implement that as a cloud gateway. Here's what you do. You will go to the cloud project here, okay? And all you have to do is just hit package. Make sure you choose release, okay? And boom, it creates all of that cloud deployment package behind the scene. But we'll be deploying this via a deploy PowerShell script. So let me just get out of this. Just hit exit. Just type exit because the console app is it's on a and a loop, infinite loop, looking for something for you, that you type, which is exit, and it gets out of the program. So what I want to do here is get back to up to the samples folder. If you can see that samples folder, I'll go back to my cheat sheet, and this is what I'll do. I'll run a PowerShell script that does a number of things. First, it calls a deploy PowerShell script. This is the name of my, my worker role, my cloud service. This is the storage. This is the location, because since my IoT hub is sitting off is Azure, I might as well have that running there as well. And besides that, I'm using a certificate, an X.509 certificate, and I'm saying that here is my connection string. Okay, so enough of talking. Let's paste that over here. When I run that, it's really nice, right? It's going to prompt me to enter my credentials for my Azure subscription. So let me just sign in using my internal Azure subscription. Sign in with my smart card. Here's my virtual certificate. Enter my PIN. Oops. All right, and the script will run behind the scene. It would create the Azure storage in which we implement that session block storage, as well as the QoS2 table queue. All right, so while this is happening, you can see it does a bunch of stuff, right? It takes about 5 minutes to do all of those things. And we're not going to wait for that. Again, I've pre-baked this. And let's hop onto the Azure portal. And I even have that open over here. Yep. So I've deployed this a couple of nights ago. It's called Pre-Ignite Cloud Gateway. And what's there is it's got 2 instances running. You can scale this up or down any way you wanted it. So it's highly scalable. And you can see the properties, everything is there. But what's interesting is that we also understand that now there are some devices which needs to contact a fixed static IP address. So what we do is, what I've done is that I've created, I've reserved an IP address, and I've assigned that to this particular cloud service deployment. So when I run get Azure reserve IP, you can see that this is the IP that I've reserved. If you guys have done this before, you can only reserve an IP through a PowerShell script, not through the Azure portal. So just remember the last few digits is 121.178. Come back here. There you go, 121.178. So this is it, all right? So what I want to do now is to very quickly change my unit tests, which I had running, where I run a couple of times. And this time around, oops, not that, of course. So let's copy that IP address, pop that here, save, and maybe just to be safe, it could be a little bit paranoid. Let me just rebuild the project and run selected test again. Now, how do I know the service is running? So now it's out in the cloud. Previously in the Field Gateway, the console app, at least I had the console logging all happening within the window itself. In this case, the good stuff is everything has been logged onto the Azure storage. And what I'll do is that I'll show you where that lies. It's go to Storage Accounts Classic. This is a new Cloud Explorer in Visual Studio 2015. And you will see I will have Pre-Ignite Cloud Gateway Store over here. Go over to the table that is called Slab Logs Table. Okay, double click on that. So in case you want to see what that looks like, is this one. Okay. Internet is running a little bit slow right now, but that's okay. And you can see the payload, it says it started, right? And it's actually listening on this particular endpoint, 8883. If I jump back to my protocol gateway, it's still running the test, but at some point, it would come back and say that, yep, it's tested okay. It's just as simple as changing the IP address of my cloud gateway, and everything works exactly as it is. So you can see that this time around, it took slightly longer. It took about a minute. Previously, with a few gateway, and of course with the latency of going to the East Asia data center and back, that incurred an additional 11 seconds. Right? So it took just about a minute to run this. So cool. So I've got my few protocol gateway, my cloud gateway. Now, how about showing a real device that is actually doing something? And for that, let me just show you other stuff that I have running here. So this is a Raspberry Pi 2. It's not running Windows 10 IoT Core, but I've left this running Raspbian. Now, a really nice feature of the Azure IoT SDK is that we have this available on a number of platforms. So when it's running on Raspbian, it's essentially C, NC99C, running on Raspbian. So that's what I have, is connected onto my switch. So let me just jump right back to show you how this actually works. Okay, it's connected. Let me just create an SSH session to this. I know that the IP for my Raspberry Pi is this. Click open. All right, let's sign in. All right. So just make sure that I have internet connectivity. Yep, all good. All right. You would have done the same thing, right? Go to the Azure IoT GitHub page here, right? Grab the URL. You would have cloned that onto your own instance, and you're ready to go. Now, the project that I'm interested to modify is one that is called Serializer. So let's go into that folder, see Serializer, and it is sitting in samples. And there's one sample for each protocol, HTTP, AMQP, as well as MQTT. Okay, first thing, let's modify my simple sample MQTT source code. Right? Now, there's only one place you need to modify, which is the connection string. Okay, how do you get your connection string? Go back to your Device Explorer. Okay, under Configuration, I'll just type gateway.contoso.com, click Update. What I'm simulating is a device called Fister Node MCU. Now, this time around, when I copy the connection string, come back to PuTTY, and paste it, you will see that I've got something additional appended to my connection string. It says gateway hostname ssl://gatewaycontoso.com, and this is the port. Now, the beauty of this is that the Azure IoT SDK actually understands this as part of the connection string. So if it sees this, it knows that, now I need to do a protocol handshake with this gateway that is running at this hostname at this particular port. Right? That's all you need to do. All right, so I'll save this. To make things simpler, I'm just going to edit my host file. Okay, and what is the gatewaycontoso.com address? So for that, let me just go back to this IP address, the reserved IP address I have running in the cloud. Come back here, paste that. Yes, and just to be sure this is set up correctly, just ping the address to see that the IP address has been updated. Yep, of course I can't ping it. I don't have that port enabled. I didn't enable ping. So good. All this is running. So right now I would rebuild. Build all under Linux. Build sh, and I'll skip the unit test. All right. So it runs that build script because I want to compile everything. So ultimately I get a binary which I can run. Let me just make sure that I've got this running, this telemetry. Let me just clear that. Okay, in a moment, I should be able to do the same. So I've got a real device, a Raspberry Pi, that's fully capable of sending MQTT with TLS enabled, and it will be using the cloud gateway to send that message over to my IoT hub. So let me just go to my Linux folder and just run this. So this is the current version of the SDK, and boom, there you go. Right? My first device, and it sends a wind speed of that. Now the interesting part of this is that this is not just one way. I can do this bi-directional. So in other words, my next step is I want to send a command to device message, which you can also do using your Device Explorer. Now this serializer example here is actually listening for a very particular JSON message. So I have my cheat sheet here. So let me just copy that, pop that into, and I have to be really specific. I'll say that I need to send this to my Feister Node MCU. Oh, hang on. Copy, paste, oops, what happened there? And send. So in a while, this would have gone to that endpoint, and boom, right? You can see that the air resistance has been set to 55. But it also accepts other commands. If I just know what is that JSON payload, copy, I can turn on the fan as well. So let's try to do that. If only I can copy. There you go. All right, in a while, you'll see that, yep, the fan has been turned on. So what we've just been able to demonstrate is that we have a protocol gateway sitting in the cloud that does all the protocol adaptation on behalf of the Raspberry Pi, speaking MQTT with TLS handshake, and is fully bi-directional, right? D to C as well as C to D. That's all great, okay. But remember I talked about brownfield scenarios, right? So how brownfield can this get to? Remember I alluded to this other device that I have? Here is that Node MCU. It's really small. That Node MCU dev kit is this. You can buy this if you can just search online. I think it sells for about $12. It's got a Wi-Fi chip built in onto it, and that Wi-Fi chip is the ESP8266. And of course, my good mate Dave Glover has got some other nice stuff to it as well, like a LED display, whatnot. There is a GitHub project for this as well. If you just go to github.com/makerdan, you will see the exact project for this. So what I want to do is that I want to connect. Now let's assume that these are my brownfield devices. I've got this installed all over my plant floor, right? And it speaks Wi-Fi, but not very capable because it cannot even do a TLS handshake. So having said that, what's going to happen? Am I going to allow this guy to talk to my cloud gateway in clear text? The answer is no, right? Because if anyone just listens to the traffic, you would see exactly all the telemetry that gets sent through. So perfect example of why I need a field. Yeah, it could be this one, but I'll need a field gateway, which is running on this particular box over here, right? So the idea is that this communicates with my field gateway, right, in a private Wi-Fi network. However, this gateway has got a LAN connection that gives it internet connectivity, right? So let me recap. This guy, no internet access. This guy, access to the private Wi-Fi network, as well as an internet connection via this cable over here. So that's how I'm going to allow a brownfield device like this talk to the cloud via a field gateway. So what do I do? Let's jump back to my demo. All right, so we're going to do some code changes. This is when it gets interesting, all right? Let's go back, let's pop back into my Visual Studio. Here's my console app, but nothing gets modified in a console app. Things get modified in a common project and it's specifically this class called Bootstrapper. All right, and so what's going on here? Okay, this is the right place. Okay, so first thing I'm just going to do a compile flag here. So if no TLS, then do this. Okay. Else, do that. Change that port to 18883 and just do an if. Okay. Besides that, where else would I need to change? I need to change this because when it runs, when the Bootstrapper runs, it says that the contract requires a X.509 token or certificate. So I will just say that, you know what, if it's not using, if it's using TLS, then do this. Okay. Where else? I should probably give a friendlier message that says that, well, if no TLS, oops, do that. If not, else do something else. So in this case, there isn't a certificate, there's only an MQTT port. So let me just get rid of this argument here. So I'm just saying that I've initialized it, it's running on this particular port. I'll just say that initializing MQTT, endpoint running here, then just do an NIF. And the last place that I'll do this is that I would remove this particular pipeline, which is for the TLS handler. So just uncomment that, and you're good to go. Now, in the interest of time, I'm not going to recompile this, and because initially my idea is to show you how I'm going to provision this software, right, onto my field gateway. But the good thing is that, of course, I would have already done that prior to my talk. So let me just run that off the device. Now, I should have my team viewer running here. So let's log on to my device. Yep, there you go. So I just want to make sure that it's well connected. Here's where I'm simulating, right? It's connected to a Wi-Fi network, and this is essentially the private Wi-Fi with that Node MCU device. Then it's connected to the internet via the LAN connection, okay? And so what I'll do now is that let me just run that program that I have in, oh, this is really small. Sorry about that. Oops, still not showing. Never mind, I've got my zoom in capabilities. Yep. All right, so let's go to Azure IoT Protocol Gateway under release. It's the same thing. Normally, you would run this as a Windows service on this particular box. So by the way, this is running Windows Embedded 8 standard. Gives it full access to the .NET framework, which is pretty much how I ran this on my laptop. So you can see that it's initialized on MQTT port 1883. Still a little bit small there, but you know that this is now, you know, the protocol gateway is running on the field with TLS disabled. So having said that, let me just connect my Node MCU onto my USB port. The reason why is because I need to do some Arduino wiring. So let me just jump into Arduino, open up my project for this. Let me just open this. So here you go. What is the IP address? Now, I happen to know that my gateway is running on this particular IP address. save that, and let me just upload onto my device. Okay, so it's actually flashing my Node MCU dev kit right now. So it's compiling the sketch, it will upload onto it. At the same time, let me just open up the actual brain behind this project. It's an MQTT services. Now what I'm doing here is that I'm connecting over to first passing the client ID. For authentication, I'm using my client IDs or the device ID as a username, and the password is actually my shared access signature. So this is a SaaS token. Now I've cheated a little bit here. Now by right, you're supposed to implement your own token service in which this guy would call your token service to get a SaaS token. But what I've cheated is that I've created a SaaS token that expires after a year. So that's what I've done, and I've hard-coded onto the device. But normally you wouldn't be doing that. You'll be creating your own token service, you'll be doing your own custom authentication before you spit out that SaaS token for your device. But I've cheated, just for the demo. Let me just make sure that the earlier project is uploaded. And now let me just upload this project as well. Right at the last mile of my demo. Now, a number of things. First and foremost, let's make sure that let me just kill the earlier, this one. Let me just kill this to make sure, because this was also called Node MCU. Let me go to data. Let's clear this. Let's see when telemetry. So I'll open up a number of windows. First and foremost, let's have my team price. Oh, what's happened to that? There you go. So when it's green, that means telemetry is coming true. That means my field gateway running on that CDM Nomad box is indeed running. Right? It's doing that protocol adaptation. At the same time, let's go to my device explorer. Good. It's sending temperature. Okay. Now that's all good as well. How about looking at this from a really nice dashboard? Okay. Let's do that. I have my dashboard open here. Let's sign in. It's getting quite exciting. All right, choose 5-star Node MCU. All right. So in a while, I should be able to see some telemetry coming through. If not, let me sign in. I've got 2 dashboards. So the good thing as part of this is that you can absolutely create as many dashboards as you want. By the way, the source code for this is also available in the GitHub project, so you can absolutely modify this. So if I zoom in, 5-star Node MCU is somewhere here. There you go, 5-star Node MCU, and I should be seeing some graphs being plotted here. But then again, not too sure why it's refusing to do that. No worries. However, you do know that this is running live. If you go to the MakerDen, and assuming they have this, I can actually place my finger onto that temperature sensor. So right before this is about 26 degrees Celsius. It should actually go up to about 27. Yeah. So right now you should be able to see 28. That shows like, I'm pretty warm here just with my finger on the temperature sensor. I've cheated a little bit. It doesn't have a humidity sensor. It's got a light sensor. So what I did is like, I replaced the humidity values with the light values. Okay, I don't want to get myself electrocuted there. I felt a little bit of current. Yeah. So there you go, right? From 70, it's gone down to 35, right? When I remove my finger off the temperature sensor, it's gone back down to about 27 to 26 degrees Celsius. All right. Okay, that shows how this is done, right? Brownfield device, going through a gateway, goes onto the IoT hub, visualize that on the remote monitoring dashboard, and there you go. So we've got some really, thank you. These are our capable partners in Australia. It's a good 9 of them. We've got some global SIs as well. In fact, the global SI are not just limited to Accenture and Avanade. There are a whole bunch of them. Here are the resources. All of the things I've shown you, the IoT suite, where you provision that, the SDK, the protocol gateway, and the GitHub project for your remote monitoring solution, they're all open source. So have fun looking at that. And also, this is the advertisement for Makerdan. So head over to the Makerdan Expo. It's just open now. So thanks so much for staying put for that 7 additional minutes. But you can absolutely head over there, try out the Azure IoT Hub. And remember earlier I said that I'm not using the Azure IoT SDK in this case because I'm doing something funky over there. One thing that Dave Glover and I realized is like when you've got devices like this, the time is no longer current, right? So we have to do our own stuff. I'll explain to you if you head over there. And of course, fill up your evaluation. Thank you very much for your time. Here are all the other talks that's available. Tomorrow, please attend Mitch Denny's session. Uli is at 11:30. In fact, I'm his demo dolly for one of the demos. Dave Glover is doing another session, and Uli is following up with a final session on Friday. And please complete your session evaluation. 5 is the highest. That means it's the best. 1 is not the best, yeah? Thanks very much, guys. Have a good Ignite.